the case for urgent direct climate cooling. The Healthy Planet Action Coalition is an international organization that advocates for an urgent and more ambitious global response to climate change. It is comprised of Ron Bayman, Jim Baird, Sev Clark, Clive Ellsworth, Leslie Field, Ahim Hoffman, Michael McCracken, John MacDonald, Suzanne Reid, Stephen Salter, Herb Simmons, Yi Tao, and Robert Tulip. The world needs a climate restoration plan that will limit global warming to below 1 degree Celsius. An effective and responsible plan will integrate 3 approaches: cooling the planet, reducing greenhouse gases emissions, including methane and other short-lived warming agents, and removing legacy carbon dioxide, methane, and other greenhouse gases from the atmosphere. The long-term average global temperature increase metric is inadequate for assessing or predicting the harm from regional or local extreme precipitation and heat events. Climate change, especially polar amplification, has already caused enormous damage and is likely to abruptly accelerate the risk of further catastrophic harm to humans and other species in the absence of urgent direct climate cooling efforts to slow or reverse it. There are at least 17 potential direct climate cooling methods that merit early consideration and responsible investigation for possible, carefully monitored, implementation. 15 of these methods are considered here. Listed in alphabetical order are: buoyant flakes, cirrus cloud thinning, extremely diluted aqua regia aerosol, fizz tops, ice shields to thicken polar ice, iron salt aerosol, making building and paving material more reflective and planting trees in urban areas, marine algal bloom stimulation, marine cloud brightening, mirrors for Earth's energy rebalancing, ocean thermal energy conversion, restoring natural upwelling and kelp forest ecosystem services offshore, restoring soil and vegetation, seawater atomization, stratospheric aerosol injection, surface albedo modification, titanium oxide aerosol, wax and ocean heat conversion. Given multiple potential methods to directly cool the climate, relying exclusively on greenhouse gases emissions reductions and removal is incompatible with responsible stewardship of the planet. Directly cooling the Earth can dramatically reduce harm, preserve ecosystems, and save lives. It is therefore imperative that world leaders urgently adopt a climate restoration plan to limit global warming to well below 1 degree Celsius. During the current critically important short-term transition period, it is vital to keep the climate from spiraling out of control. Only the application of emergency cooling tourniquets, applied immediately or as soon as is reasonably advisable, has the potential to slow or reverse ongoing climate disruption and worsening climate impacts, while reducing emissions of greenhouse gases and removing these gases from the atmosphere and ocean take effect over the longer term. Only direct climate cooling can potentially slow or reverse Arctic sea ice melting, which is an imminent climate tipping point. These are the imperatives, challenges, and opportunities of our epoch to which we must immediately and urgently respond. Humanity has never faced an existential threat so critical for the survival of human civilization and our fellow living species on this planet. The current greenhouse gases emissions reduction and removal strategy accepted by the IPCC will not avert accelerated climate calamities in the near future. Polar ice regions will continue to melt and sea level will rise, triggering extreme weather events and overstepping ecosystem and climate tipping points of no return. But this is not inevitable. We can apply direct climate cooling to try to minimize these calamities in the short term and give us time to restore the climate and regenerate the natural environment in the longer term. The argument that direct climate cooling should not be researched or implemented because it is a moral hazard that would slow greenhouse gases mitigation efforts, could have unanticipated consequences and lead to termination shock or harmful climate destabilization if abruptly ended, and would be difficult to govern equitably, are general arguments that could be applied to other efforts to reduce climate and environmental harm. Climate adaptation, for example, was initially opposed as a potential moral hazard that could reduce pressure to cut emissions, but regulations to reduce harmful sulfur emissions from cargo ship bunker fuel have reportedly had the unintended consequence of causing a significant global warming termination shock. Equitable world governance is a major problem for rapid and at scale global emissions reductions. The long-term average global temperature increase metric is inadequate for assessing the harm from regional or local extreme precipitation and heat events. Climate change and especially polar amplification has already caused enormous damage and is likely to abruptly accelerate the risk of further catastrophic harm to humans and other species in the absence of urgent direct climate cooling efforts to slow or reverse it. Since there are multiple potential methods to directly cool the climate, relying only on greenhouse gases emissions reductions and removal is incompatible with responsible stewardship of the planet, given the opportunity to directly cool the Earth in ways that dramatically reduce harm, preserve ecosystems, and save lives. It is therefore imperative that world leaders urgently adopt a climate restoration plan to limit global warming to well below 1 degree Celsius. The need for relevant climate change metrics and goals. The 30-year moving average of global surface temperature that is used as the primary climate change metric is a lagging and an inadequate measure of harm being experienced from climate change. The IPCC and COP's use of the time-averaged increase in global average temperature change as their metric, a metric developed early on by scientists to get a strong signal-to-noise ratio, downplays the change being experienced by peoples and countries and fails to portray the seriousness of present and potential impacts. With respect to observations, averaging over time rather than calculating the present value from a linear or nonlinear trend analysis significantly understates the amount of present warming and proximity to the Paris Accord's warming goals. Averaging over time also fails to account for the year-to-year and shorter-term temperature excursions due to variability. Many types of impacts are most dependent on short-term excursions rather than decadal average departures. Recent events are making clear that the worst impacts are from short-term weather extremes, such as flooding precipitation, prolonged heat waves, etc. The current key climate impact global average temperature rise is also a metric that virtually no one experiences. Warming is greater over land than over the ocean, especially in mid and high latitudes, and very especially in the Arctic, so most people are experiencing warming greater than the average. And for those in regions of below-average warming, changes in precipitation are generally the most important impact, either through prolonged heat waves and much drier conditions as the subtropics expand or much wetter conditions as the trapped heat in low latitudes increases ocean evaporation and leads to more intense and prolonged precipitation. Neither the globally average temperature metric nor the focus on projections out to 2100 provides useful insight into the likely and ongoing amounts of sea level rise. Paleoclimatic analyses suggest an equilibrium sea level sensitivity of about 12 meters per degree change in global average temperature. The present rate of warming is some 10 times faster than the average rate of warming during the deglaciation phase from the last glacial maximum, during which the average rate of sea level rise was 1.2 meters/century for 100 centuries, while the global average temperature was rising at an average rate of 1 degree every 10 centuries. The recent IPCC assessment giving assurances that the rise in sea level by 2100 would be less than a meter is far from convincing, given the increasing rate of flow of glacial streams coming off the Greenland and Antarctic continents, and geological evidence that ice sheet decay occurs much more rapidly than ice sheet formation and would be very hard to stop once initiated. A 2022 NOAA technical report estimates that even if greenhouse gases emissions neutrality was reached now, existing levels of greenhouse gases in the atmosphere and oceans will, in the absence of direct climate cooling or other countermeasures, lead to 0.6 meters of sea level rise along the U.S. coast by 2100. The internationally proposed goal of reaching net zero emissions as a way of halting climate change fails to recognize changes in the global carbon cycle being caused by past and present emissions. As defined by IPCC, the net zero calculation refers only to direct human-induced emissions, that is, emissions in national inventories. This would be fine were the natural emission and uptake of greenhouse gases staying constant, but this is not the case and will not be in the future. Already, Arctic and Amazon basins have shifted from being natural sinks of carbon dioxide to natural sources, and the thawing of permafrost, warming of coastal sediments, ongoing forest conversion to farmland, occurrence of wildfires, and more are reducing natural carbon uptake and storage and increasing natural emissions. By the time human-induced emissions reach net zero, net natural emissions will be strongly positive, and so global warming and climate disruption will continue. Counterbalancing these emissions with human-induced negative emissions will be very challenging given the magnitudes involved. NOAA has reported a superlinear increase in methane year over year that has a biogenic origin based on the stable isotope studies, a profound realization of a potential tipping point. Methane levels are now 3 times higher than they were pre-industrially. Scientific studies have tended to focus on offsetting warming from 2 or even 4 times the pre-industrial carbon dioxide concentration. While interesting sensitivity analyses, these have been totally unrealistic in any practical or political sense. Much more relevant have been initial studies aimed at incrementally counterbalancing future warming, so first stabilizing the climate at the present level of warming, and then slowly bringing the global average temperature, an adequate metric that is, back down toward its mid-20th century value. As an overall goal, the policy needs to be to not let the situation get worse and then take actions to minimize the alterations to the climate that have occurred. In doing the research to evaluate how best to proceed, 3 points need to be considered. First, the risk of not immediately slowing or reversing polar amplification. Second, based on current trends, we are poised to begin crossing the first climate tipping point, Arctic summer sea ice melting, within 2 decades, as by this time the Arctic is projected to be ice-free during the entire month of September. Third, multiple other studies using different data and methodologies suggest that crossing this tipping point would lead to a collective warm season radiative forcing impact increase from 1979 equal to that of more than 20 years of greenhouse gas emissions at current rates. Climate models and measurement methods have underpredicted the thinning and loss of Arctic sea ice retreat per degree of global warming was 2.1 times larger than the mean of a large suite of models, and a recent 2021 study found that from 2002 to 2018 Arctic ice has thinned 60% more than previous estimates. From 1971 to 2019 the Arctic warmed 3 times, and from 1979 to 2021 nearly 4 times, faster than the global average, increasing the frequency and severity of extreme climate events. Disproportionate warming affects all 3 poles, including the Himalayan pole at the top of the world. This polar amplification is accelerating ice sheet loss in Greenland, the Himalayas, and the Antarctic. Global warming is accelerating the melting of Himalayan, third pole, and other glaciers that are critical to the water supply of billions of people. Current levels of global warming are already causing calamity. A 2021 report by Christian Aid found that the 6 years with the costliest, over $100 billion, climate disasters have occurred since 2011. And a recent Wall Street Journal article also notes that bad weather is a major factor in the 2021 run-up in regional and global energy and commodity prices, including wheat, tin, coffee beans, natural gas, fertilizer, cement, steel, and plastic, including resins, additives, and solvents. If we do nothing to try to prevent or slow the loss of Arctic sea ice melting and reverse global warming, these impacts will get worse and the risk of crossing other even more catastrophic tipping points will increase. We simply cannot afford to allow devastating harm and increased risk to accelerate for decades until we achieve net zero global greenhouse gas emissions and the highly disrupted climate to persist for decades after, until legacy greenhouse gases are pulled back out of the atmosphere and oceans. Estimates are that climate calamity and suffering will continue until over 1 trillion tons of carbon dioxide equivalent greenhouse gases have been removed from our atmosphere and surface oceans. The claim, without evidence or study, that the risks of trying to cool the climate, regardless of method attempted, will always be greater than the risk of not attempting to do so, cannot be justified a priori. Delay in beginning to intervene to offset at least some of the global warming, as emissions continue at high levels, will cause immeasurable and potentially avoidable increased human and species suffering. Many of the approaches to offset climate warming mimic natural influences on a climate of everyday human activity and can be quickly terminated if unrecognized adverse impacts do arise. These points have recently been recognized by many prominent national and international scientific and policy associations and think tanks, but unfortunately not by national or international climate decision-making bodies. Methods for direct climate cooling. The following is a menu of proposed direct climate cooling approaches that we suggest merit early consideration and responsible investigation with actions that can be monitored and reported on. They are listed in alphabetical order with short summaries for most of the methods that are written or reviewed by climate cooling experts. It is our recommendation that many of these methodologies be researched and evaluated for simultaneous, complementary implementation. We do not, however, wish to imply that all of the below methods are needed in every case, as further research will no doubt make clear which methods show the most promise and are best suited for achieving their goals with the lowest costs in financial, material, and energy terms, and with regard to other important economic or social and environmental objectives in particular situations. Brightwater uses micron-radius hydrosols to substantially brighten surface waters at very low volume fractions of parts per million and energy costs. Buoyant flakes are buoyant rice husks coated with waste mineral powders rich in the phytoplankton nutrients of iron, phosphate, silica, and trace elements that are typically deficient in warming surface waters. The mineral's ultra-slow release is intended to provide a sustainable basis for an enhanced marine food web. Cirrus cloud thinning would seed high-altitude tropospheric cirrus clouds with ice nuclei seeking to cool the planet by allowing increased long-wave radiation reflection to space. Extremely diluted aqua regia aerosol is a naturally occurring acidic aerosol in the oceanic boundary layer, formed from volcanic and sea salt sources. Fizztops are table-sized, floating, lightweight, solar-powered units that are designed to inject nanobubbles into the sea surface microlayer. Ice shields could be made by pumping polar sea water to the surface to thicken Arctic sea ice in the winter. Heat released by freezing would be emitted to space during winter, while in the warmer months the increased surface albedo would cool the ocean and slow the melting of sea ice. Iron salt aerosol is based on dust-driven chemistry that has occurred naturally over the ocean in the troposphere for millions of years. It depletes tropospheric greenhouse gases and renders smoke particles more easily washable out by rain. Making building and paving material more reflective and planting trees in urban areas would tend to cool urban heat islands by, respectively, increasing reflectivity and evapotranspiration. Marine algal bloom stimulation would try to stimulate large-scale plankton and seaweed blooms to cool the planet by increasing ocean and marine cloud reflectivity. Marine cloud brightening is a climate cooling approach that turns salt water into mist to make marine clouds reflect more sunlight. Mirrors for Earth's energy rebalancing involves deploying mirror arrays on the Earth's surface to reflect excess downwelling solar radiation as a means of decreasing local, regional, and global temperatures. Ocean thermal energy conversion, also known as thermodynamic geoengineering, utilizes the temperature difference between surface and deep ocean water to cool the planet while generating base load energy and removing carbon dioxide from the atmosphere. Ocean upwelling and kelp forests fertilize and cool constructed seaweed forest platforms can be powered by solar, wind, tide, ocean thermal energy conversion, or wave energy. Restoring soil and vegetation to cool the planet through evapotranspiration captures carbon and regenerates ecosystems. Seawater atomization uses anchored wind turbines to spray seawater droplets into the lower atmosphere to increase evaporation and long-wave radiation of its heat content. Stratospheric aerosol injection mimics the impacts of sulfate aerosols from volcanic eruptions like the 1991 Mount Pinatubo eruption that cooled the planet by an estimate 0.6 degrees Celsius for 15 months. Surface albedo modification brightens ice and snow to slow melting and potentially restore reflective ice mass, reducing a range of climate impacts. Titanium oxide aerosol is a method of reducing the rate of polar and mountain ice melt during summer months by shielding melting ice fields and open polar ocean surfaces from direct sunlight with white fog and clouds. Waxen ocean heat conversion uses the self-ionization effect in water to enable the conversion of aqueous heat to chemically stored energy. The need for an urgent call for direct climate cooling in addition to greenhouse gas reduction and removal. While perhaps theoretically possible, insufficient and unfulfilled government commitments, economic realities, and the sheer magnitude of the task make it unrealistic to think global greenhouse gas emissions can be cut in half by 2030. A 2021 United Nations Environmental Programme report said this would be necessary to have a greater than 66% chance of keeping global warming below 1.5 degrees Celsius through the 21st century. The World Meteorological Organization estimates that there is a 50% chance that the annual average global temperature increase will temporarily reach 1.5 degrees Celsius in at least 1 year by 2026. Fossil fuel aerosols, notably sulfur in shipping, have an estimated 0.5 degrees, 1.1 degrees Celsius cooling impact. If this is withdrawn, existing legacy greenhouse gases in the atmosphere and oceans would cause the increase in global average temperature to exceed 1.5 degrees Celsius and possibly 2.0 degrees Celsius. Recent research suggests that even if emissions were stopped immediately in 2022, the level of greenhouse gases already in the atmosphere, otherwise known as legacy greenhouse gases, will produce above 2.0 degrees Celsius warming before 2100. Based on the changes in the climate, polar ice extreme events and impacts, the Earth's temperature is already higher than is compatible with successful achievement of the United Nations Sustainable Development Goals. The only way to prevent ever more frequent and severe catastrophes is to urgently apply direct cooling tourniquets to our bleeding planet, as we work to cut emissions and remove sufficient greenhouse gases to cool and stabilize the climate. Equitable reductions in greenhouse gases emissions would need to support economic development to offset the estimated $4 trillion in foreign exchange from oil and related products that countries comprising 1.1 billion people, or 14.2% of world population, depended on in 2019 for over 10% of their total export revenue. We urge world leaders to immediately adopt a climate restoration plan to limit global warming to well below 1 degree Celsius that will include cooling the planet, particularly the polar regions and the Himalayas, reducing greenhouse gases emissions including an early focus on methane and other short-lived warming agents, and removing legacy CO2, methane, and other greenhouse gases from the atmosphere and oceans. In the absence of a committed effort to directly cool the planet, the accumulation of greenhouse gases in the atmosphere will cause untold damage and suffering for generations to come while disproportionately impacting the poorest and most vulnerable populations. Achieving the IPCC goal of having emissions to keep average warming below 1.5 degrees Celsius, or even the only slightly less unrealistic Paris Agreement goal of having a 66% chance of keeping warming well below 2.0 degrees Celsius, or below 1.8 degrees Celsius, would require the equivalent of 8 rounds of 8.3% year-over-year global greenhouse gas emissions reduction from 2022. Relying on this approach alone is incompatible with responsible stewardship of the planet, given the opportunities to directly cool the Earth in ways that dramatically reduce harm, preserve ecosystems, and save lives. In conclusion, direct climate cooling is quicker, more effective, and less costly for most methods than either the sharp reduction in greenhouse gas emissions proposed by the IPCC or greenhouse gas removal and ecological regeneration. As well, governance approval of direct cooling should be more feasible than deep emission cuts, as it does not require a complete transformation of global industrial civilization and of our relationship to nature. If wisely implemented, direct climate cooling could restore many ecosystems, protecting and enhancing biodiversity by allowing many areas that are becoming too hot to live to become habitable again. By immediately reducing extreme weather, direct cooling could save many lives. By mitigating warming and sea level rise, it could radically reduce climate migration and resulting risks of conflict. Though some fossil fuel interests have played an extraordinarily destructive role in combating the climate crisis, for which they should be held accountable, fossil fuel use in general was not an original sin but the basis for modern industrial civilization. Addressing the climate crisis is, at least in the short term, not fundamentally a moral and political problem, but a practical environmental and technological problem that must be addressed within existing social and economic systems. Addressing our immediate emergency crisis by use of cooling approaches that can moderate global warming allows for a more realistically feasible pace of emissions reductions and for the time needed for ecosystem restoration and regeneration. This would provide an opportunity for humanity to evolve from a fossil fuel and mineral mining civilization, dependent on discovering and mining fossil fuels and minerals in particular locations, to a potentially more equitable, prosperous, and ecologically sustainable, renewable energy and materials civilization able to harvest energy and use minerals from the ocean and carbon from the air to synthesize materials almost everywhere on the planet. This shift would replace our current wasteful and destructive practices with a circular economy where all waste is recycled as a resource. However the world proceeds, equity and environmental justice issues must be addressed to meet the Sustainable Development Goals. Climate justice requires a focus on issues such as safe harbor for climate refugees, support for loss and damage from climate disruption, and transfers of funding and technology for climate restoration and ecological regeneration from rich to poor countries and individuals. Doing this rapidly within decades and at scale will likely require a mandatory global regime. Over the 13 years 2006 to 2018, the Clean Development Mechanism that was part of the mandatory Kyoto Accord transferred $303.8 billion from rich countries to poor countries for mitigation and adaptation. In contrast, the Paris Agreement voluntary during our current critically important short-term, at least several decades, but possibly much longer, transition period, it is vital to keep the climate stable and prevent it from spiraling out of control. Only the application of emergency cooling tourniquets, applied immediately or as soon as is reasonably advisable, has the potential to slow or reverse ongoing climate disruption. Only direct climate cooling can slow or reverse Arctic sea ice melting, which is near to becoming a climate tipping point. These are the imperatives, challenges, and opportunities of our epoch that must be immediately and urgently taken on. Humanity has never faced an existential threat so critical for the survival of human civilization and our fellow living species on this planet.